Hello everybody, Mrs. Logus here, and this is page 4 of your Chapter 8 review packet, and this page is focusing on word problems with right triangle trig. You are 30 meters from the base of a tree. The angle of depression from the top of the tree to the ground is 61 degrees. What is the height of the tree? The angle of depression from the top of the tree to the ground is 61 degrees. Okay, so what we have here is we hope that the tree is perpendicular to the ground. So I'm going to create a right triangle here, and I'm going to label the sides by what I think is going on based on the word problem. So you're 30 meters from the base of a tree. A base, another word to say that, is the bottom of the tree. So this right here has to be my 30 meters. The angle of depression. Now technically, the angle of depression is if you're standing up here, it's your sight as you look down from the horizontal. And the angle of depression is the same as the angle of elevation because those are alternate interior angles and they are congruent to each other. So let me write a note here that the angle of depression is congruent to the angle of elevation. So that what that means automatically is that the 61 degrees is here, but even better, it's within the triangle as the angle of elevation, which is right there. The question is, what is the height of the tree? So what you're trying to find is how tall the tree is. So if I draw the picture again a little bit more neatly based on what I have 30 here, I have X here, and I have 61 here. So based on the angle, because all of trig is based on the perspective of the angle, we have the opposite side and we have the adjacent side. So if I have opposite and adjacent, if I think about SOHCAHTOA, this is the t or the tangent because we have opposite and adjacent. So if I make my equation initially, we'd have tangent. Technically, you're thinking tangent of your angle is equal to opposite over adjacent, or more clearly, tangent of 61 degrees from the perspective of 61 is the same as opposite x over adjacent 30. Because I have the angle, we are not using inverse trig. Instead, we're putting this over 1, and we are cross multiplying. When I do the work for that, that would be x times 1 equals 30 times tangent of 61, or x by itself equals 30 times tangent of 61 degrees. And so this time the x is by itself. So in the calculator, you need to type in 30 times tangent 61. And if you do that, you would get that your value is 54.12 meters. Problem 20. A ladder leaning against a house makes an angle of 48 degrees with the ground. So here we have a ladder, and it makes an angle right here of 48 degrees with the ground. The foot, another way, is another word that is a synonym with bottom of the ladder, is 7 feet from the house. So the 7 feet is going to go on the bottom. This, again, is a right angle because you hope that the house is perpendicular to the ground. And the question is, how long is the ladder? Remember that the ladder is leaning against the wall. So the hypotenuse is the x this time. So if we're basing on the angle of 48, what we have this time is the adjacent side and the hypotenuse. If you consider SOHCAHTOA as a way to remember the trig functions, this time I have adjacent and hypotenuse, which is cosine. So cosine of my angle is the same as adjacent over hypotenuse. That is my basis equation. So that would be cosine of 48 degrees from the perspective of 48 equals 7 over x this time. Because I have the angle, we would again put this over 1 and cross multiply. This time, if I show that work, I would get x times cosine of 48 degrees equals 7. And so this time, to solve for x, I need to divide both sides by the cosine of 48 degrees. So in the calculator, I would type in 7 divided by cosine of 48. Let me do that right now. You would get 10.46, and we're finding a side length in feet. So 10.46 feet is the answer for the length of the ladder. Number 21. There is a flag flying at the top of a flagpole. The flag is 35 feet off the ground, and you're standing 25 feet from the base of the pole. Again, base is again another word for the bottom of the pole. What is the angle of elevation? Well, to elevate your eyes means if you were standing here looking up at the pole, this right here would be the angle that you elevate your eyes, or the angle of elevation. This time I'm trying to find an angle. So as soon as I'm trying to find the angle, that means that I use the inverse idea or inverse trig in this problem. So if I were to set up a problem initially, here I have the opposite side compared to the angle that I'm trying to find, and this is the adjacent. I know I've been doing this every time, but I'm doing it just to make things clear. This looks like, again, that this is a tangent situation because we have opposite and adjacent. So we have tangent of my angle is equal to opposite over adjacent, or tangent of I don't know equals 35 over 25. Now, if I write that equation again up here, the reason that we need to use the inverse is because we're trying to get the x by itself. And the only way you can get tangent to the other side is not by dividing it, because there is no angle attached. So instead, I need to apply the inverse on both sides of the equation. So x is equal to the inverse tangent of 35 over 25. The reason these cross out is because they are inverses of one another, like a squared and a square root. So in the calculator, you would press the button second, and then you would press tangent. If you do that, you get the inverse popping up, and you get 35 divided by 25 in the parentheses. So that would get you an answer of 54.46. And this time we're talking about an angle, so the correct unit should be a degree symbol. And yes, we are looking for the degree symbol on the test. Last trig word problem here. Luke is flying a kite and realizes that 400 feet of string are out. So we have 400 feet, and I'm thinking that the string is most likely not straight up and down because we're going to have some kind of wind here. The angle the string makes with the ground is 50 degrees. So if we picture this, here is the angle that the string makes with the ground. So if I draw the triangle more clearly, we have a 50-degree angle here, and this is 400 feet. How high is Luke's kite above the ground? So we're trying to find this height here. So if I were to create an equation, this time we do not need the inverse because we know what the angle is, but we do have opposite and hypotenuse here, which, thinking about right triangle trig, this is sine because we have opposite and hypotenuse. So sine of my angle, or sine from the perspective, is equal to opposite over hypotenuse, or sine of 50 degrees equals x over 400. If I cross multiply, because I have the angle, and I go like this, show the work, we have x equals 400 times the sine of 50 degrees. So if I do 400 times sine 50 degrees, I would get that x is 306.42 if I round. So my answer is 306.42 feet. And this is where I'm going to end this video. This video is just the trig word problems. I hope this was helpful. Thank you so much.